So the properties of logarithms are the different things we can do with the logarithms themselves, and we're taking them from working with exponents. In all the rules that we talked about with exponents last couple of days, we were talking about, if we multiply with the same base, we add the exponents. Divide with the same base, we subtract them, and if we raise to a power, then we multiply them. And so we're going to use those things, and you started to take a look at them on that handout we were working on, and we're going to go ahead and just put that all together today. So here's a reminder with the first one is the product property of logarithms, and that goes with the fact that when I multiply with the same base, I add exponents. So here's the product property of logarithms. It says that if I am multiplying two numbers together, so if I take the log of a product, then it equals the log of those things added together. So here, like what we were looking at yesterday on the handout, we had something similar to this, except it was base 10, log base 3. Oops. Okay. So it says the log base 3 of 1,000. Well, I can write 1,000 as 10 times 100. Okay? Or I could write it as 10 times 10 times 10. So that means then with the rules of logarithms then, because we're talking about exponents, I can take the log base 3 of 10 and add the log base 3 of 100. So basically this is a way of simplifying a little bit, making it easier to work with. So that property then is here. If I have the log base b of m times n, so it doesn't matter what the base is, it could be 10, 3, 7, whatever you want. That means then I can break that product up into two things and add them together. The log base b of m plus the log base b of n. Okay? And so you're going to want to make sure that you write all these properties down somewhere so you have easy access to them. So here's our example. And this property works both directions. It works if I'm adding with the logs of the same base, then that means I can multiply. Or if I have the log of a base with a product, then I can pull it apart and add. So for this problem here then, we can say this is the log base 6 of 4 times 9. Or log base 6 of 36. And then it says simplify as possible. Can I simplify this? So think about it. We're looking for an exponent, right? When I'm doing a logarithm, I'm looking for an exponent. Is there an exponent that makes that a true statement? So we're thinking about what we were doing yesterday with switching them from exponential to logarithmic form. So this basically says, is there 6 to some power that equals 36? Yes or no? Okay, 2, right? So this is equal to 2. So I simplified it, said it's the log base 6 of 36, and, I wrote it as a single logarithm, made it the log base 6 of 36, and then in this case I was able to simplify it and get 2. So we have the single logarithm and the simplification. So if we're adding logarithms with the same base, that means I can take those numbers here and multiply them. Or if I'm multiplying with the same base, I can pull them apart and do the log of each one and add them. All right, so you guys do both of these two. Okay. Right? Now, when we're dividing with the same base, we subtract the exponents. And so the same thing works with the property for logarithm. That when we're dividing, take the logarithm of a quotient, then we do the log of the numerator minus the log of the denominator. And so this one says that the log of base b of m over n is equal to the log base b of m minus the log base b of n. There's that exponent rule. Okay? When we have a quotient, we subtract the exponents. Because remember, when I do a logarithm, I talk about exponents. So basically all we're doing is we're subtracting exponents here. Says the property above can also be used in reverse, but there is a caution. Okay? Be careful, because if the bases are different, then you can't add or subtract them, right? Depending on the situation. So whatever, as long as the bases are the same, you can add if you're multiplying, you can subtract if you're dividing. Or if they're subtracting them with the same base, you can write it as a quotient. It's a division problem. So here we have the log base 5 of 100 minus the log base 5 of 4. They want us to write it as a single logarithm, and then if we can, simplify it. So since I'm subtracting here, that means it's the quotient property. So that tells me that I have log, still base 5, that doesn't change. But I'm going to do 100 divided by 4. So the log base 5 of 25, and that equals 2. What's that? Because when we have the same base and we subtract exponents, okay, that means we're dividing those two parts, okay, with the same base. Okay. So when the property is subtraction, that means we have a quotient there. Okay, so dividing. Because you can multiply logarithms, you can also take powers of logarithms. Okay? And so the power property goes along with the property that says that if I have b raised to the power of m to the power of n, then I'm going to take b raised to the power of m times n. So the power property is that if we do the log base b of a raised to a power p, then I can actually take that power and I can move it to the front. And so it becomes p times log base b of a, because we're doing it that many times. If we're going to multiply it together that many times, we're going to add it together. So here's this example here. It says I've logged the 10 cubed. Well, that means the log of 10 times 10 times 10. So I have the log of 10 plus the log of 10 plus the log of 10 using the product property, which how many of them am I multiplying together? 3 of them. So I can just say 3 times the log of 10. And so what that tells me is that I can take that exponent and I can move it to the front, okay? The power property. So it says express it as a product and then simplify if possible. So as soon as I see this exponent here, I know I can take that and I can move it to the front. So this becomes 6 times the log base 2 of 32. So what's the log base 2 of 32? Is it what? Why is it 5? Okay. 2 to the 5th power is 32. So this would be 6 times 5, which is 30. So here's our product. 6 times the log base 2 of 32. And when I simplify that, I get 30. Letter B, we have log base 8 of 4 raised to the power of 20. So I can take this 20, since it's the exponent just for a single logarithm, I can move it to the front. So this becomes 20 times the log base 8 of 4. Now, can you simplify the log base 8 of 4? Is 8 raised to a power equal 4? Okay, not one that you know of, right, off the top of your head anyways. Okay, all right, we're actually going to, so we wrote it as a product, and this can actually be simplified further, and I'm going to show you how to do that later. Okay, we're going to come back to it in just a couple minutes. All right, next one. Exponential and logarithmic operations undo each other since they are inverse operations. So here we have the inverse properties of logarithms and exponents. So the inverse properties, the first one says if I have log base b of b raised to the power of x, this equals x. Or if I have exponential b raised to the power of log base b of x, it just equals x. And the thing you can kind of think of it this way is because these are inverse operations, logarithms and exponents and exponentials are inverse of each other, whenever these two things are the same, the b's there or the b's there, whenever they're the same, I just get whatever that exponent is. The value is just x because those two things are undoing each other. Okay? So since the logarithm and the base are undoing each other, that means then we're going to end up just with x for our answer. Okay? So whenever you have the log base b of b raised to a power, okay? So here they have log base 10 of 10 to the 7th power. Well, think of it this way then. We could write this as, that part there, we could say that's 7 log base 10 of 10, right? Right? And since this is equal to 1, the answer there would be 7. Right? Okay. Here's a little bit different, though. Right? So if we've got 10 log base 10, 2, if we change this then to log, it's in exponential form right now. Okay? If I change it to logarithmic form, I would have, here's my base, here's my exponent, here's the answer. So I would have the log base 10, that's this 10 here, of 2 is equal to the log base 10 of the answer, which is 2. Okay? Or we could look at it this way here. The log base b of x, so this b comes here, and this x comes here. And what is it equal to? It's equal to the log base b of x, the exponent. So if we were to think of those as changing them from exponential to logarithm or logarithm to exponential. They would put us in the situation to where you would say, okay, these two things have to be equal to each other. So we're looking, our key to it is are the base here and the base here, are they the same? If they are, it just equals the exponent. The answer for letter A is 11. Now letter B, they don't come right out and tell us the bases are the same. But can I write 81 as 3 to some power? 1, can you? All right, check it out. Tell me, does 3 to some power equal 81? What, 4? Okay. So I could rewrite this as a log base 3 of 3 to the 4th power, couldn't I? Because 81 is the same as 3 to the 4th power. So then this just equals 4 because these two things are the same. And letter C, since both of these two bases are 5, the answer is 10. And so let's think of it another way for this one. That I could say basically that this equals x, some unknown. So then I could change the way it looks. Here's my 5 is my base, so I could say the log base 5 of this x here is equal to the log base 5 of 10. So that means then that this x and this have to be the same because I have log base 5 and log base 5. So x equals 10, or my answer is 10. Okay? So if I ever switch it, you can also think of it as switching it from exponential to logarithmic form, and things should turn out to be equal to each other then. Most calculators can calculate logarithms only in base 10 or base e, which is something we're going to be looking at in lesson 7.6. You can change a logarithm in one base to a logarithm in another base with the following formula. Now, this is called the change of base formula. Now, I'm not going to tell you this, or I'm not going to show you where it is, but this change of base formula is actually, it is on the calculator. Okay? I mean, not the formula itself, but there is a, if you have a base other than 10, you can use your calculator to find it. You just have to do some hunting and searching for it. Okay? But I'm going to show you the change of base formula because this actually helps you to understand some of the stuff we're doing also. So this says if I have the log base b of x, it equals to the log base a of x over the log base a of b. And when I do these problems, I don't even worry about this being some other base. You can, but you can just do it as log, you can do it as the common log and just say the log of x divided by the log of b. Because for the most part, you're just going to use the common log on your calculator. So where they said log base 2 of 8 and the log base 2 of 4, well, that makes sense also because the log base 2 of 8, 2 to what power is 8? 3. So this equals 3. And the log base 2 of 4 is 2. So that equals 3 halves. Okay. So the nice thing about doing it this way is with the using a base that actually works with your numbers is you can do it mentally and find it, okay, instead of having to punch it into your calculator. So I'm going to show you the two different ways to do this, using base 10 or using a common base. So here you want to evaluate the log base 32 of 8. And the base is always going to the denominator. Okay? So this is the log of 8 divided by the log of 32. We're going to use base 10 first. Oh, my calculator will do that. Log of 8 divided by the log 32. And that's 0.6. Okay. Now, the other thing we can do is use a common base, a base that works for both these numbers. So what base has exponents that equal 8 and 32? So if I raise something to a power, it equals 8. If I raise that same thing to a different power, it equals 32. What number would that be? Can I do 4 to a power and get 8? Is 4 squared 8? No, it's 16, right? Okay. Can I do 2 to a power and get 8? Yes, 2 to the third, right? Okay. Can I do 2 to a power and get 32? Yeah, we looked at it a couple minutes ago, right? It was 5. Okay. So I could write this as a log base 2 of 8 and a log base 2 of 32. Well, because 2 to the third power is 8, and 2 to the fifth power is 32. I would end up with 3/5, which is also same as 0.6. So you can do it either way and get the correct answer. Okay? The main thing to remember is that the base always goes in the denominator. Whichever one you do it with, the base has got to go in the denominator here. Okay? And now, don't confuse this with subtraction. This is what some students do. They confuse the change of base formula with subtraction, that they'll try to do the log of 8 minus 32. Or if they see subtraction, they'll do the log of 1 divided by the log of the other. And it's not. When we're doing subtraction with the quotient rule, it's the log of m minus the log of n. Okay? Or the log of m divided by n. All right? So now, let's go back here. Right? And I told you we could simplify this one. All right? So now I want you to simplify this 20 times the log base 8 of 4.